Now we are going to finish the first stage, or the thermal stage. It consists of a furnace. This is our reaction furnace, and also it contains a waste heat exchanger. Finally, we need to add a condenser. So here we are going to look for a condenser. This one is a waste heat exchanger. This is a sulfur condenser. So we are going to add this one over here, and this will be our condenser. Okay, double click to open it. Okay, and we will have this one. This is our condenser 100, and the feed we want to call the outlet. Okay, so WHE, outlet gas. This is our inlet gas stream, and the outlet gas stream in this case will be the cold one. Okay, and also we'll have a sulfur outlet. This is the sulfur that will be condensed and exit as a liquid. So in this case we will have a condenser 100. We are going to copy the name, the condenser 100 outlet gas. Okay, so gas outlet, and also we'll have this from the same condenser 100 liquid sulfur outlet. Okay, sulfur outlet. Okay, now we need to add an energy stream, so it will be condenser 100, because we will have a lot of condenser here. Okay, energy, especially in the second stage. So you need now to add, it's given that you have a known delta B. So in this case we are going to add from the parameter we are going to add the pressure or the outlet temperature. So from the parameter, the outlet temperature from the condenser, we need it to cool down until 135 degrees Celsius. Okay, after that it will be okay. After adding the temperature, this is the delta pressure or the pressure drop that going to happen through the condenser. This is the amount of temperature that you want to decrease. You need to lower the temperature, but negative 165. This is the intermediate percent. Okay, these are zeros, so it means nothing here. This is for the worksheet, the temperature in, the temperature out, and for the temperature out will be the outlet for both liquid sulfur and also the gas outlet. Okay, here you can have the properties and the composition. We are 100% sure that the condenser sulfur will be 100%, must be here 100%, so this is almost 100%, but here you have some traces from H2S. Okay, so now we have our condenser and it's converged. So this is our first stage, furnace, WHE, and a condenser. After that we need to add our second stage, which is catalytic. Okay, so in this case we are going to configure the catalytic stage. The catalytic recovery of a sulfur consists of 3 steps: heating, catalytic reaction, and the condensation. We have discussed this before in the previous video. Okay, most of the time you can have it 1 or 2 stage of the catalytic reaction. Okay, and a typical sulfur recovery subflow sheet may contain between 1, so you can add only 1 catalytic stage, or 4. Okay, so you are going to add 4 heaters, 4 condensers, and 4 catalytic reactor. In this case we are going to start by adding a heater. So this one is a heater. Okay, heater to increase the temperature before entering the reactor. Okay, so because we mentioned before, the temperature inside entering the catalytic reactor must be higher than the dew point of sulfur, because we don't need any deactivation to happen to the catalyst. Okay, now you have your condenser 100. Okay, this is your condenser 100. In this case we are going to call this one heater, maybe heater, and the inlet here we want to increase the temperature of the gas outlet. Okay, so this is the gas outlet. The energy will be E100 energy, and the gas, the outlet here will be E100 gas outlet, or the heater gas outlet. name it whatever fits you. Okay, now you are given again that you don't know the delta B, but in this case we know that we want to heat this stream until reaching a temperature, an outlet temperature of 270 degrees Celsius, and also we know the delta B is 0.4 psi, so 0.4, and from here we choose psi. Okay, so unknown duty. So after adding the exit temperature here you are given that this stream must be heated until reaching a temperature of 270 degrees Celsius. Okay, after that it will be okay, and now it's also converged. So after that we have added here a heater to increase the temperature, and now we have this temperature to be 270. Next you need to add your catalytic converter. Okay, how to get the catalytic converter? From here. Okay, you will look for a catalytic converter. Okay, this one is this is a catalytic converter. We are going to take it and add it here. Okay, we want to zoom out, so here, and our catalytic converter will be here. Double click to open it. This is your first converter. Okay, so the inlet will be our gas that we get out from the condenser, and the outlet in this case will be our converter. This is our first converter number 1 outlet. Okay, after adding, it's all done. You don't need to add any parameters, but here you need to check the catalyst. Okay, in this case we are working with a catalyst, aluminum catalyst. Okay, and this is the first thing to understand. Second important thing is H2S SO2 reaction is 100%. This number means the catalyst, all the catalyst is active. If you add any number less than 100%, this will mean that the catalyst is not totally active. Some of it has been deactivated. So if you add 80%, which means that 80% of the catalyst only will be working. Okay, and it's important to start with 100. Now we add after that we add a heater, we had our conversion. Now we need to add the third part from the second stage, which is a condenser. So again you are going to, I think we have installed a condenser before, so now we are going to add another condenser. But in this case this is not a normal condenser, it's a sulfur condenser. So this is a sulfur condenser, so we are going to add it here, and again we are going to zoom out. Okay, and we add a condenser. Okay, not this one. We are going to add a condenser here. So this is condenser 101. Okay, and we double click here. We know that we want to lower the temperature of the conversion one outlet. Okay, and the outlet gas in this case it will be our condenser 101 outlet. Okay, and the liquid stream will be a condenser. This is a condenser 101 liquid sulfur outlet. Okay, and also you need to add a energy stream, so it will be condenser 101 energy. Okay, you can add right Q. Okay, again you are asked to add a delta B. So in this case we do have outlet temperature. You want to cool this stream or lower its temperature until it reaches 135 degrees Celsius. Okay, now it's totally converged from here. Okay, for the condenser. Also you can add the delta B, the pressure delta B here. You are giving it to be 0.4 psi. Okay, so 0.4 psi. Okay, which is equal to 2.7 times 10 with negative 2. Okay, so now we are done here. Okay, I just want to double check on the psi here, because this condenser also have a parameter that this one is 0.4. I just need to double check. Actually it was the heater, so the heater, there is a pressure drop which equals to 0.4 psi. 0.4 psi. Okay, and we are good now. I'm just double checking that I enter the data is right. Okay, now we have this is our first catalytic stage. It consists of a heater, a conversion, and a condenser. Okay, now I'm going to add another one, a second catalytic stage. It will be the same, but instead of going and creating this three stages separately, you have here a combination. In the palette you have something in common and a combination. Okay, so from a combination tab you can add a catalytic section. Okay, this one is a catalytic section, this one is a thermal section. So instead of creating it myself the same way I did before, I can take this one and add it to simulation environment. In this case I'm going to add a catalytic section, take it like this and put it here. Okay, this one, and put it here. I think I have a problem because of the space, so let me zoom out again and take this one and add it. There is another option, so double click on it. Okay, so now it's added. It's heater. Okay, let me zoom out a little bit. Okay, it's a heater here, a heater, a conversion, and a condenser. Okay, so zooming out in and moving this direction and up. Okay, so now you will have this one. This stream, the first stream, we don't need it because we will connect this stage or this section, or as it is a catalytic section, to the previous section, so we want actually to delete number one. Okay, in this case we will connect it, the heater number one, and replace it with this one, the condenser one outlet, because we want to again to feed this one to a heater and the conversion, and we call the product. Okay, so open the heater and add condenser one outlet. Okay, now we have an outlet which is number 2. It's actually named here, we don't need to change it, and this is E11 unit, this is E100. There is a pressure drop here equals 3 kilopascal or 0.4 psi. So we are given here that we have maybe kilopascal, which was kilopascal this time, and it will equal to 3 kilopascal. This is a pressure drop that is going to happen inside this heater. Okay, also we are given that the outlet temperature from the heater is stream number 2. The temperature is 220. Okay, so the temperature is 220 degrees Celsius. Now you will find out that the heater is done, all the data for the conversion is okay. Now we need to figure out the condenser. Okay, so the conversion, if we enter here by double click, in this case we can choose another one. Instead of using alumina again, we can use titanium. We can choose titanium, this one. Okay, after choosing it, you will have that the volume or the space velocity must be specified for titanium catalyst. Okay, so in this case you need to enter more data. In this case we are going to add another information which we are asked, which is space velocity. In this case you are given the space velocity is to be 1001 per hours. Okay, so this is your speed. After pressing OK for the space velocity, you will have the catalytic converter fully converged. After that you will have a condenser. Okay, double click on the condenser. This is your condenser 1 or 2. The inlet is number 3 and the outlet is number 4. And now you are given that the outlet gas temperature is 135. Okay, so the outlet temperature should be 135 degrees Celsius. Now all of it is fully read. Okay, we have a question here related to the recovery, sulfur recovery. If we enter here this one and we look at the performance, we will find that we have a sulfur recovery. Okay, this is in kilogram per hour. You can also have sulfur recovery as efficiency, which is 96%. Okay, so that's where we find the percent of the recovery or the amount of recovery, okay, from the performance of the sulfur condenser. Okay, in the next video we are going to talk more about the direct fired heater that we can add in the simulation.